What's going on, everyone? In this lesson, let's go over linear approximation. It's also called linearization, okay? And so this method allows us to approximate the value of a function, all right, some function f of x, at a particular point A, meaning evaluating some function where x is evaluated at A, okay? And to do this, there is a formula for this approximation, and it looks like this, right? So L for linearization of x is equal to the original function evaluated at A plus the derivative of the function evaluated at A multiplied by x minus the value A, okay? So this is our formula that we're going to work with today, okay? It's quite simple. So let's do an example. And let's say I wanted you to find the linearization, or the linear approximation of this function. F of x is equal to square root of x plus 5, right? And I wanted you to approximate that at a is equal to 4, okay? And so this function approximated at 4. And so we know that our function is this, right? I'm going to copy it from the question prompt. And we know that we can rewrite this as f of x is equal to x plus 5 raised to the 1/2, right? And so in our formula that we're using for the linear approximation, we're going to evaluate the original function, in our case, x plus 5 to the 1/2, at this value, 4, okay? And so if we evaluate the original function at x is equal to 4, we get 4 plus 5, which is 9. And essentially, that's going to be square rooted, right? Square root of 9, we know that that's going to be 3. All right, so we already have one part of our formula, all right? Now we need to find the derivative of our function. So the derivative with respect to x, okay, x of our function f of x is the same thing as the derivative with respect to x of, and let's use this form, right? Because these two are the same thing. So let's use this one because this is more easily differentiated, plus 5 raised to the 1/2, right? And so we are going to chain rule this thing, right? So the first thing is going to be the derivative of the entire thing. So we're going to take this 1/2, we're going to multiply it by the 1, the coefficient here. So we're going to get 1/2, leave all the stuff inside, x plus 5, subtract 1 from your exponent. So 1/2 minus 1 is negative 1/2, okay? This is the term for the derivative of the entire thing, right? In terms of the concepts we talked about. This is entire. We're going to multiply that by just the stuff on the inside. The stuff on the inside is x plus 5. So the derivative of x plus 5 we know is just 1, right? Because the derivative with respect to x of x is just 1. And then the derivative of a constant is 0. So multiply that by 1. And this was our ddx of just the inside. After we put all this together, you're going to get f prime x. I'm going to use the shorthand now, right? Because f prime x and this, right? These are the same. You can use either this one or this one, but since we're already kind of into the course, I'm going to start using the shorthand. So it's going to be 1 over 2 times x plus 5 to the positive 1/2 If you're confused on how I got this, remember that 1/2 times x plus 5 to the negative 1/2. This negative 1/2, right, just means that you're going to take the reciprocal and then your exponent is going to be positive, meaning the 1/2 is the same. Instead of x plus 5 raised to the negative 1/2, you're going to have 1 over x plus 5. Now flip the sign of your exponent to the positive 1/2. Okay, and this is the same thing as the square root of x plus 5. Okay, over 2 times the square root of x plus 5. All right, and so this is our derivative. And so our linearization formula wants this derivative evaluated at a, or at 4 in this case. So f prime, all right, 4. So put 4 in here, that's square root of 9, which is 3. 3 times 2 is 6, so this is going to be 1 over 6. Okay, so now let's plug everything in. This is our f of a right here, right? This is our f prime a over here, right? And so let's put these into our formula. L of x is equal to f of a is 3 plus 1/6 x minus a, which in our case is 4, right? Because we were evaluating this function at this value. And now all we have to do is simplify. So L of x is equal to 3 plus 1/6 x minus 4 over 6. Let's try to turn 3 into a fraction, right, that has the denominator 6 so that we can combine these numbers. This becomes 18 over 6. Okay? 18 over 6 is the same thing as 3. Minus 4 over 6 plus 1/6 x. Okay? And then I'll finish it up here. L of x is going to be equal to, I'm going to put that x term first, and then this is 18 minus 4 is just 14 over 6. This ends up being your linearization, okay, of x plus 5 to the 1/2 at a is equal to 4. Okay, so this one was fairly simple. So given your function, all we're doing really is just plugging in to our formula here, right? And so let me give you one, and then you can spend a couple minutes on it, and then we'll work through it together to see if our answers match, right? So find the linearization for f of x is equal to x plus 3 at a is equal to 1. Okay, so function value, your formula is going to be f a plus f prime a times x minus a. Okay, so go ahead and pause the video and give this a try, and then we'll go over together. Sweet. So let's see what we got going on, okay? So we know that the first term, we need the original f function evaluated at 1. We also need, right, the derivative of this function evaluated at 1, okay? So let's just plug in 1 to our original first. So this is going to be 1 plus 3, right? 1 plus 3, all square root. 1 plus 3, all square root. That's the square root of 4, which is just 2. So f of a, right, is 2. Let's find the square root of this thing. f of x is actually x plus 3 raised to the 1/2, right? Now the derivative of this is going to be the chain rule, all right? And so that's going to be the d dx, the entire thing multiplied by the derivative with respect to x, or just what's on the inside. And so let's do the entire one first. 1/2 times 1, which is the coefficient here, is 1/2. The stuff inside stays the same. Don't change it. Subtract 1 from your exponent. 1/2 minus 1 is negative 1/2. That's your d dx of entire. Now multiply that by the derivative of the inside, which is just x plus 3. Derivative of x plus 3 is just 1. Okay? And so your f prime x looks like this. Right? Same thing we did before. X plus 3 to the negative 1/2. Right? X plus 3 to the negative 1/2 is the same thing as 1 over x plus 3 to the positive 1/2, which is just 1 over root x plus 3, right? And so this becomes 1 over 2 root x plus 3. Let's evaluate this at a is equal to 1, right? So f prime a is equal to, you put a 1 here, that's 4. Root 4 is 2. 2 times 2 is 4. So this becomes 1/4. All we got to do now is take this, plug it into our formula, okay? So linearization at x is equal to f of a is 2, plus f prime a is 1/4, 1/4, x minus a, which is just 1. And all you do is simplify. 2 plus 1/4 x minus 1/4. Let's change 2 into a fraction that has a denominator of 4. So we can combine the two. This is going to be 8 over 4 because 8 over 4 is in fact 2. So 8 over 4 minus 1 over 4 is 7 over 4 plus 1/4 x. Okay? This is your function. Okay? This is your answer for the linearization. Okay? So if this made sense, good job. If it didn't, you're totally fine. Just go back and look at the parts where you need help, okay? And if you have any questions or comments, please feel free to leave them below, and I'll get back to you as soon as I can, okay? This was linear approximation, or also called linearization, right?